We have Joe Kenny, who's our Director of User Experience for our business and has worked with a lot of our customers just to provide some guidance. And he's going to go through how to create a consistent user experience across your system. So, Joe, go ahead.
Alrighty, thanks, Jimmy. So, folks, I'll just introduce myself again, but Joe is fine. Some people call me Joseph, but Joe is great. I've been doing this at GE for approximately 10 years now. And essentially the thing that I really want to talk about is a lot of times when folks talk about creating a consistent user experience or high performance HMI, they honestly think of the graphical part, which is obviously the most impactful. We get 90% of our information through sight. But the reality is that it really is, in order to do true high performance HMI, it really starts with the process. And so one of the things I like to remind us all of when we're doing this is that the H in HMI stands for human. A lot of times, we all do this. We default to creating machine interfaces, but we don't create human machine interfaces. And what I mean by that is we tend to technically put what we need on the screen and say, when I click this button, the activity happens that I expect to happen. But is it obvious to the user that you're targeting, the persona, the person that's supposed to do this day in, day out? Is it obvious that they're supposed to hit that button? Is the time sensitivity of their interaction really explicit in how you're doing the screen design? So you have to remember at the very start of this, for instance, if you come to a juncture where you go, really, we need to update our screens. So it's not just simply a transfer to another technology, which isn't simple in reality. But on top of that, you're saying, look, we actually are going to change our business process for how we're going to work and allow ourselves to be more efficient on the plant floor. That's really what high performance HMI is about. It's not about just switching over the graphics. It is about business process change. So you have to consider certain things. You have to consider, what are the goals for the success criteria? Not simply how do we update the screen, but why are we updating it? And what, most importantly, not only what are we showing, but what are we going to elect not to show anymore? What's the work environment like? Are we talking about people that are service individuals that are going out to wastewater facilities, for instance, and they're in a truck and their laptop is bolted to their dashboard? Are they on a tablet device or are they in a control room facility? And what are the conditions in the control room facility? Is it a dark environment? Is it a bright environment outside in the sun? Those kinds of things. What's going on in the rest of the day of that person? So what are their challenges and distractions? Are they going to be able to focus and complete a complete multi-step task, or are they interrupted commonly? And does the software, for instance, allow for that hold time and doesn't time out on the user, for instance? Those kinds of things. So one of the things I like to talk about, and I won't belabor this slide, but one of the things that folks have to do when they're designing the HMI is they look at the different personas they have. And these are very common high-level personas. But for instance, when you're designing an HMI screen, one of the common mistakes is you say, well, we'll design the screens for all the personas. So the screen will work for everybody. That is not high-performance HMI. High-performance HMI is when you say, I am going to design a screen for the operator, and specifically the operator's tasks. That narrows the scope of what you're doing. It will inevitably simplify the screens. In some cases, yes, you may end up designing an additional screen to maybe cater to, let's say, the maintainer or the administrator. But the reality is, oftentimes, too much data on the screen slows the users down, and it costs more than actually just maintaining and developing that initial separate screen. So from there, for the rest of this presentation, I'm going to assume that we've focused on the operator, the person doing an explicit task. And one of the things I like to talk about is perception. So I won't ask anyone on a conference call. I sometimes do this in a room, but most people, when they see this image, they might see a duck. But if you turn this image sideways, how many people now see a rabbit?
Mm-hmm.
And it's all about your perspective, all about where you're standing. It's not that either one of those scenarios is wrong. It's that you interpret it by the way you are set in perspective to it. So, one of the things, for instance, you have to consider is understanding the user's environment. So, for instance, this is a lift from a typical high performance HMI screen. This is more GE style internally of doing these things. And you're looking at different cues and visual cues. For instance, you'll notice that the gauges that represent pressure kind of curve in, so it gives a visual kind of indicator that that's a certain kind of gauge. A straight up and down fill gauge is rectangular. The one that has the bulb at the bottom is the thermometer. You have other ones that are, as I said, flow, etc. But what happens when you're, for instance, in different scenarios? So, you know, you want to reduce anything that distracts from the real job. Let's be honest, you're trying to process water, you're not trying to learn a software program. So the reality is you want to make sure, no pun intended, you want to make sure you go with flow, so to speak. You want those screens so that when the operator's looking at those screens, it's integrated into their day. I mean, I would spell success if we tried to take away the screens from the operators. They go, I can't live without those. That's what we're looking for in UX. That it actually helps me do my job. In a monitoring situation, usually it's about 6 screens that are in a control center, maybe more, but usually efficiently, if you narrowed it down, it's to 6. If there's an event, 4 of those screens will highlight. So you have to understand how you can bring focus to the 4 screens that have an issue or have prominence. You want to make sure you understand if there's distractions, noise level, is there eye strain? Are they interacting with touch or a mouse and a keyboard? That can make a lot of difference in the specificity or how tight the screen can be designed with clickable regions. But I'll go back to eye strain. This kind of visual, this bright kind of visual, works very well on a factory floor setting. Where you do have to tendency to bright lights, or if you're in a truck or something like that. And again, you have the laptop scenario bolted down to the dashboard. But in a control center, in a monitoring environment, you might take the identical screen and just dim all the colors and give them dark mode, because that's easier on the eyes in a low light environment. So there may be manufacturing environments that are low light environments too, and this would be better than the factory floor that maybe is making appliances that is brightly lit. Maybe you're more in a manufacturing environment where you're making computer chips and lasers are running and you want the lights dimmer in that environment. So I'll go from there, and I'll first say this before I go to the slide. If Jimmy told me, you're running over, Joe, you only have one slide you can talk to these folks about, it would be this slide, to be honest. And it really is the second step. The first step is picking the persona, by the way. So the first step is picking that you're looking at operators, and then the second step is, and this is the most important part of doing high performance HMI. It is focusing on what the users need to see, and quite frankly, get all your folks into a room that are going to be making decisions how the HMIs are, and start doing the 5 whys process. And what that is essentially this. You go, why is displaying the KPI important? So this is a typical scenario. The graphic I'm showing you is an older HMI. You can see it. It's got the shaded tank, and it's definitely not a high performance graphic. And it's showing the fill level. And through the color, it's showing that there's a critical condition and the low level is marked. And you've also got the amount of liters of fluid that's there. And you've got the unique identifier of which tank it is as the label above it. And it goes, the operator needs to ensure that things are working properly. So, that's at a very prima facie level. So then the next question you ask is, why is this value significant? What does the operator, What does it let the operator know? So the answer might be, well, why is it significant? Because it allows them to see the fluid level of the tank so they don't run out mid-production of whatever fluid they're using. Okay, so you can see a scenario here where if the fluid's lower, I've actually changed it more to a high-performance HMI graphic where I actually have an alert symbol next to it in case you have someone who's colorblind. For instance, the first scenario I showed you wouldn't work for someone like that because they might not be able to see the difference between the blue and the red. Or they just might look like two different shades of gray to them. You can see that the numbers are more aligned to each other in terms of how to scan left to right, looking at 68 and 19, and that it's on a leader setting. That's all in the same place. Everything is aligned. The name of the actual object that's on the screen is more prominent and again scannable and aligned. And you'll also see that the pipes are highlighted of which pipes are active, which pipes are shut off, which are intake, etc., are all labeled and organized in a way that can be easily aligned. And again, this is all about scannability. But then you ask the next question: why is showing the actual numeric value to the operator necessary? You might be surprised to know maybe it's not. Maybe it's that they don't actually have to know what level the fluid's at. They just need to know there's about 20% left, because they want to make sure that they know when it needs to be refilled, but they don't really care about it up and coming. They just care when it gets to that 20% because they still have time. And then it's, why is 20% significant? Well, we find out from that this gives them enough time to switch the tanks and indicate to the maintenance that the tank needs to be refilled. So in other words, they're not the one to refill it. So we've reduced the graphic now to a little icon, the name, and whether it's filled to the right level and okay to use or not. And then the task becomes, if I click on the tank, I can switch the tank, and then I have to send a message to maintenance to go tell them they need to refill that other tank I switched from. So then the last question is, why is the operator required to tell maintenance? Couldn't switching the process automatically tell them? So in other words, it becomes one click now. So when I click on that, two things happen. The tanks get switched, and it sends the message to maintenance that the tank should be refilled. This full scenario is actually high performance HMI. And a lot of people usually stop at line 2. They make it look better, but they don't actually make it work better. And don't get me wrong, there's nothing wrong with this scenario, this one, but this would actually be the interface that the maintenance person would get so they can see how full the tank is, because they are responsible for filling the tank. But the operator doesn't need that clutter on their screen. They only need to know, is it good to go or is it not? And when I click this action, it's going to do two things and I don't have to worry about it. So it greatly reduces the process. So what I like to warn people of is when they say, hey, I want to do high performance HMI, it's not just the redesign of the screen. It's actually a redesign of the process. It is business process management change. If you do it right, you will change your workflow. So just wanted to point out some obvious things. When I say that things are made for different audiences, for instance, plant manager may be mostly interested in an overview screen, so it can lean in that direction in terms of information. Operators really exist in the middle ground. They have primary control over things and they can delve deep into a subsystem. But when it gets to the diagnostic part, that's really maintenance. Operators don't usually go to that level. So it's not like you have to create a duplicate screen for everything. I mean, this isn't an array. You can go from the overview all the way down to diagnostics. But understanding that when you design the different screens, say, okay, this is primarily going to be for the plant manager or the operator or maintenance in this case. So you have the level, and I'm sure most people are familiar with this, level 1, 2, 3, 4 screens, etc. But it's something that principally still holds true now with high performance HMI. Just want to show you quickly some examples of just how you need to think about the design attributes. So for instance, these are two distinct layouts. One's of a like literally a circuit breaker box board for a large power company. The other one is actually a train car and how loaded it is. So one of the things that's interesting is the scan space. So people scan in either an F pattern, so they're scanning it kind of like you would scan an Excel spreadsheet. They kind of go across the top of the columns, then they go to the next level, and they go to the next level and continue that down. Or they do a Z pattern. And the Z pattern is more for things that have status across the top, and then more of a, I would say, an architectural plan kind of diagram. This is actually the top view of a train car, and it shows you various different information in different spots. And then they scan across the bottom to see any specific details. More detailed level information is usually at the bottom. So there's these two patterns to consider. Another thing to consider is just font usage. There's a lot of fonts that are out there, and people sometimes go a little wild with it. And I like, using different styles like most people, but the reality is serif typefaces aren't great to use because they have a lot of extra detail in them, and at small sizes they render in a weird way. If you use special fonts that like have set drop caps and things like that, like this 5, it can throw off your data entry or your fields. If you see wide fonts, you don't want wide fonts because you have serial numbers and things like that may be 28 characters long, and that field will have to be that long. Condensed typefaces, look how close the S and the 5 are, in terms of just trying to read it, or even the decorative one where if you only look at half of like the 8, it could look like a 3. So you have to be careful of that representation. So it's all these different things that, they could be anywhere from overly complex to easily misinterpreted. And then, what you do want to select, and we actually use this in our software, we use Roboto, which is from Google. It's an open source typeface, but it essentially is designed specifically for computer software. So I'll give you the best example just to be brief here. But for instance, you'll notice on the monospace version, there's a slash through the O to definitely indicate that that's a 0, not a capital O. So this is very helpful when you are doing things like serial numbers or locations and people aren't sure really what kind of character it is. It has different weights so that you can do things, and we did this in the previous HMI screen. You make the value bolder because that's most important, and then you make your measurement, lighter in typeface so that once people know you're in liters, they know that probably the whole screen is in liters. Therefore, this may become less important. They only want to scan the bolder thing. Another thing that I just like to show, and this is just a very high level, but it's a design example, is that, alignment is really, really important when you're doing design. So when you're laying out your high performance HMI and you're doing your different components, laying them out not necessarily how they exist in the real world and mimicking exactly what's in the real world, organizing them in a scannable fashion can be more useful to the end user than actually what it might look like, in front of them. So for instance, changing things like the size of the dots or the size of the components in it will actually build hierarchy. So obviously the larger dot is the most, important, and the smaller dots are the least important. And it feels like you're diving down information, and this has nothing, this has no type in it or anything. There's no reason for anyone to interpret that except with size. You might place something out of place intentionally to draw attention to it. Or you might make a different shape, or you might make a different color or contrast. All of these things are minor changes to this, but that dot is now the most prominent dot with the line around it because we just flipped its orientation in terms of color. So where does this exist in real practice? This is a small excerpt from an HMI. We've got a valve, we've got a pump, and we've got a motor. Let's say that they are balanced visual weight at this point. They're all as important to each other. No one of these is any more important than the other. But let's say I'm the operator. I'm the person that's in charge of motors. I care about what the pump's doing. I care about what the valve's doing, but I really care about what the motor's doing, because that's my job to make sure that's running optimally. So you might lay out like this instead. and give myself a little more information and a little more visual information with the actual gauge running, because the RPMs are really important to me because that's what I'm trying to monitor. I do need to know that the pump is running and that the valve's open and things like that, but it's not my primary responsibility. So layout's very important, and sizing. The other thing is color. So I'm sure you've heard this, but between 30 and 40% of people that work in factory environments and or technical environments that are doing maintenance, they have a certain level of color blindness. It's particularly high in males. It's very actually rare to have a woman who has color blindness, to be honest. It's extremely rare. But for instance, I ask, for instance, my designers to actually design their screens in grayscale first. That making sure that all the prominence in their designs is just, very seeable and very apparent without the use of color. Then when they're done with that, I have them go to full color. And obviously this enhances and helps the user experience, but it does allow them to know that their designs will work for that audience that may have those visual issues. And then the last thing I just wanted to cover is animation, and this is always a tricky one. You really want to be careful of how you use animation because it's extremely powerful. So for instance, for the generator example, I'm going to physically click on, this start button. And when I hit the start button, what's going to happen is it's going to flash and then it's going to spin. And that's telling me that the generator is starting up. And then when it's started up, then it tells me the power is on and it shows that the lines are active. That is a useful animation. Having an animation showing a spinning fan, if that has no relevance to what the operator needs to know, they just need to know the fan's on or off, it's better to use an on and off indicator than actually having an animation, because that's distracting visually from the data they may really need to see. So that's a startup animation. The compressor animation is another one, and this will show multi-states. So for instance, if this is a live gauge, and it's going up and down with the numbers within the permissible area, and then it goes over the permissible area, it shows me that I'm in at some level of alarm. And then as it goes further, to be compliant with some standards, it actually is 18.2 standards. It's actually flashing now and showing the alarm. So it's containing all kinds of information through the animation. It's showing me that where I'm in range, where I'm out of range, when I creep into a different state, and changes color and the symbol as I go into a more critical state. And so using animation that way is the best way, because it's actually valuable information that helps the operator, offset an issue like this and maybe prevent it from getting to that red state. Obviously, this was very abbreviated and quick, escalation, but wanted to show you that. And so the thing that I'd wrap up with is that just think about it. Go back to that first slide where we talk about making it human. You want to make sure you're telling a story to the operator. You want to make sure that the screens that you're creating for them resonate with them in terms of their task and what they've been asked to do. Review high performance approach, the high performance book that's out, the high performance, making high performance HMI. It's a great book. It is not a complete book. The thing that it doesn't really do is talk about process change. It talks about the graphics a lot, which I think is all relevant. But the part that they do not talk about is the fact that you're really trying to streamline your process. Select that single target persona, outline a progressive hierarchy of the screens you're going to do, explain new screens and workflow, showcase specific benefits, and that's to your users. Bring the actual operators into that design process. Walk through the scenarios, and then you want to identify all specialized, graphical elements, anything that's special. To be honest with you, that most HMIs really use very, very similar methods of indicators, and really can be out of the box in many cases. When you do change something, make sure it's worth the change. And obviously, understand the organic nature of high performance. One of the advantages of a tool like OpsHub is it's easy to update. And so, as you see users maybe having difficulty, maybe you make a tweak to your screen, as you find those issues, and it will streamline and make your manufacturing more efficient. So just to show you very quickly, just some of the quick conversion outlines. This was actually a gas turbine interface that was done years ago. Applying these principles to it changed it from this to this. Now, it's not necessarily less complex. It doesn't have less things in the screen, but it is a lot more scannable and a lot more organized because of the principles that we were talking about, like alignment and scale. This one's a beautiful screen. It has a lot of information on it. It went from this to this. And then this was a plant startup screen. It went from these 4 screens to this one screen. And then this is actually in our demo software, I believe for iFix. Correct me if I'm wrong, Jimmy. But this was done, and this was using the high performance handbook rules. And even doing this, the difference between that and applying what we talked about process, we went from this to this. And then lastly, best for last, a water example. So we did some experimentation a while ago and went, wow, some of these water screens are really complex. How could we simplify them? And we looked at ideas of like placing Google Maps in the background, doing different overlays, things like that. How could we make the controls a little more like panels and come in and out? We went from this to this.
Thanks for watching. If you found this video insightful, click here to watch the next video and learn how GE Vernova is at the forefront of tackling challenges in the water and wastewater industry.